Well, ladies and gentlemen, I would like to welcome all of you to our symposium today. I would welcome the people who are sitting here in person, and I also would like to welcome the people watching us over their screens. Konbanwa to the people watching the symposium out of Japan, and konnichiwa to the people who are here in Ottobahn. First of all, I would like to thank our host very, very much, Mr. Spatz, the president of Panasonic, and his team, who really enabled us to come over to this wonderful place. It's very interestingly shaped. I think it looks like a spaceship somehow. Very modern, very inviting, very inspiring. It's like, being in the future. And I think this fits perfect to our topic today, which is the smart city. A smart city, I think, is a definition of, how to interconnect, interlink, and make a city very efficient, sustainable, and accommodative for human beings. We all know that in 2030, 60% of the world population will live in cities. And the question is really, how can we design cities in order to accommodate people there? And how can we make them sustainable and at the same time efficient? And we all know it's not just one sector, it's mobility, it's water management, it's grid management, everything is interconnected and communicates with each other. It's a very complex topic. And for that reason, I'm very happy that we have excellent speakers here today who guide us through the topic. Mr. Ortlepp, Professor Ortlepp will be the keynote speaker. I would like to welcome especially you and, of course, the speaker colleagues who will speak to us about this topic in a few minutes. Well, DJW was set up or founded in 1986. Quite a long time ago, and it was set up in order, to support the relationship, the economic relationship between Germany and Japan. This, I think, had different cycles over the time. We are talking about over 30 years of history. And I myself, looking at the geopolitical developments nowadays, would say that our relationship, which was always trustful and very solid over the time, is more important than ever. And I just mentioned that at our General Assembly. I think looking at what is happening on the political traffic and visits, we could see the German delegation led by our Chancellor, Mr. Scholz, visiting Japan for consultations, for governmental consultations with 6 ministers, is a demonstration, I think, that our relationship is very much important for further cooperation, whether it is economically driven, whether it's politically driven. Defense-driven is a topic, of course, because we all know what happened after the Ukrainians were attacked by the Russians, that it is very important that we can defend each other, and defense is also a very research-intensive topic, but also a very costly thing. And also, I think here cooperation is the topic of today. Well, again, thank you very much to our great hosts today. Thank you for the venue. Thank you for catering for our members and guests to here to the place, the members who came over, who are here today. It's really a very gorgeous sign to DJW. Well, I would like to close by that, and I look forward to listening to the speech of the Japanese ambassador, who could not be here in person, but there's a video message by him, and I would like to ask you to welcome him by joining me and clap our hands.
Dear Mr. Wiesheu, dear Mr. Spatz, Mr. Narukawa, Ms. Pomzel, Ladies and gentlemen, thank you very much for the opportunity to greet you at today's symposium with the theme Thought on the Future of Our Cities. I remember well during my time as Consul General in Munich from 2014 to 2017, I attended each of the DJW Asanokai breakfast meeting held there and exchanged views with a wide variety of business representatives, including Ms. Pomzel. For 2.5 years now, I have held the office of Ambassador of Japan in Berlin. Unfortunately, I was not able to attend in person in Munich for scheduling reasons, so I would now like to address a few words to you in the form of this video message. In view of the corona pandemic and Russia's attack on Ukraine, there is currently renewed awareness in Germany of the risk associated with high dependence on specific regions across a wide range of areas such as energy, key infrastructure, critical minerals, and the markets. As a result, interest in risk mitigation, de-risking, and diversification is increasing. In the midst of these developments, high-level exchanges between Japan and Germany are closer and frequent. In March of this year, Chancellor Scholz visited Japan together with 6 cabinet members of the German government and a business delegation. This was the first time that Japan and Germany held intergovernmental consultations, and the main topic was economic security. Chancellor Scholz also attended the G7 summit meeting in Hiroshima last weekend. Furthermore, a total of 10 meetings of G7 ministers have been held in Japan so far this year, to which, among others, cabinet ministers have visited Japan. Mr. Wiesheu was also involved as the head of the visiting business delegation, and as Germany has in this way rediscovered the importance of Japan as a partner with which it shares fundamental values such as democracy, human rights, and the rule of law, the partnership relations between Japan and Germany are now closer than ever before. And this is not limited to the political level. I heard that FC Bayern München, which has so far been involved with China, will visit Japan in July for the test match against a team from Japan's J League. I sincerely hope that through such close bilateral ties, the business connections of all participants today and the economic relation between the two countries will continue to develop. I would also like to express my gratitude once again to DJW, which has played a central role in promoting economic exchanges between Japan and Germany to date, for hosting today's symposium, which comes at just the right time. With regard to today's topic of the smart city, Japan has a high level of technology and experience. For example, Panasonic, which is providing today's venue, operates at Tsunashima Sustainable Smart Town in Yokohama. In the field of transportation mobility, the Bureau of Economy, Trade and Industry of the Tube region, home to thriving automotive industry, and the Greater Nagoya Initiative, a Nagoya-based organization that promotes international economic exchange, visited the Bavarian state government and BMW headquarters in Munich last November. Among other things, they exchanged views on CO2 neutral automobiles and the next generation mobility, so it is hoped that there will be cooperation between the regions in the mobility sector. In addition, there are also examples of cooperation in terms of energy in smart cities that aim to decarbonize. For example, it was announced in 2021 that a subsidiary of the Japanese company JFE Engineering will supply a waste-to-energy plant to the German company Lomonta, a leading manufacturer of waxes. I hope that today's symposium will also discuss the various ideas that Japan and Germany are pursuing for their extremely ambitious goal of decarbonization and digitalization. I would now like to conclude this greeting with my best wishes for the further work of all participants and for the success of today's symposium. Thank you very much.
Yeah, hello and welcome, dear Mrs. Pomser, dear Mr. Wiesheu, dear speakers, guests, partners, employees, colleagues. Warm welcome. Here in our Panasonic campus Munich, here specifically in the CXC. My name is Johannes Spatz. I'm the CEO of the Panasonic Industry Europe, and please allow me to give you some few words about the Panasonic, but even more about the place here and the idea behind. So actually, I think the Panasonic is well known as one of the Japanese big companies. So we're talking about a company of 250,000 employees and roughly, how much is it? 8.4 trillion billion Japanese yen, so about 65 billion euros, just to give you an idea about. Yeah, Panasonic as a holding is covering 7 companies, actually, divided in 5 areas. We call it the lifestyle, connect, automotive, energy and industry. We here as a Panasonic Industry Europe representing mainly the areas of energy and industry in the whole European areas with roughly 26 sales offices. So headquarters is here in Germany, so perfectly fits, I guess, to the Japanese and German relationship. We know very well, day by day, how it works and which challenges and chances we are facing in this setup. So I think that's basically to our company organization. But I really would like to explain a little bit the idea and the purpose, the goal of this Panasonic Campus Munich and the CXC. To do so, I would like to give you a short introduction by a short video and would like to explain a little bit about this direction.
The Panasonic Campus Munich is the corporate brand center for Panasonic in Europe. The Panasonic Campus Munich is more than a comprehensive showroom that focuses on presenting competencies and innovative products. We inspire our guests to embrace out-of-the-box thinking, start new collaborations, and ultimately boost business growth. With our offices, laboratories, and training rooms, the Panasonic Campus Munich is a location where brand representation meets innovative working environments.
So I guess you could see with the mask which timing we started this campus and the CXC. Actually, the idea came up in 2019 and we built up in 20 and opened in 2020 this campus. Yeah, what's the idea of a campus? Basically here the location, as I mentioned, is the European headquarters of the Panasonic Industry Europe. And so the idea was how we can bring different Panasonic areas from all the different areas together in the first step. Therefore, we have now different Panasonics here at the place, but also in addition to bring some universities, startups, partner companies at one place. So that's the first step. But the second is how to make use of these competences, how to make use of these different companies. Therefore, it needs an inspiring place where we can share the ideas, where we can make ideas tangible, and therefore the idea came up here for the so-called Custom Experience Center. We have here different so-called competence areas, mobility, retail, home, factory automation, and so on, as a competence area, just to inspiring. We have in the center, we have different meeting rooms, so it's not just to watch, it's also talk about, to share, and even more, we have surrounded with a lot of technical laboratories with service center, technology center, training centers for our customers. So we are also able here with these different laboratories to make such ideas tangible, to talk with the customer, to talk also in between the different companies. So it should be really a type of, I should say, innovation and collaboration platform here at that place. And this brings me to the topic of today, innovation, collaboration. I think if you talk about smart cities, about smart transportation, I think the big challenges for the future, how we live together in the building, in the infrastructure, in our way to commute, to transport, I think it really will need a lot of innovation, but it will need a lot of collaboration. I think nobody, even a huge company, can do something alone. It needs this interface, this connectivity, this collaboration of future ideas to challenge the changes we are facing in terms of demographic change, environmental change, energy supply change. I think these are the topics. Most probably we will hear a lot of them today from our speakers, and I'm really look forward about the speeches on the one hand, but also the discussions in the podium. So I wish us very interesting event, very good symposium, and as said, I'm happy that it's here in our campus. Thank you very much.
Ladies and gentlemen, dear guests, dear DJW members, welcome. A warm welcome to our DJW Symposium in 2023. All of you here with us in Ottobahn at Panasonic Industry Europe, also in the live stream. Welcome to everybody. And the fact that we are once again choosing a very topic, the very heart of the pulse of the time, shows, for example, a most recent McKinsey study. And this study said, it asked 4,000 people in Europe how they would like to see their future of mobility, which means of travel they will be needing to get from point A to point B. And the result was that a lot of people would like to do a multimodal mobility concept, and those are becoming more and more popular and more increasing, especially among the younger generation. And also that flexibility, sustainability, and shared options are playing an increasingly important role. In addition to all of that, the value and the importance of overall ownership of goods and services is going to play a less important role in the future, and it will lose importance in favor of the pure use of mobility concepts and methods. For young people, in addition, also the car will lose importance as a status symbol. And this fits in very nicely and very well with the concepts that both Germany and Japan are working on, programs and projects that will make cities, transport and traffic routes, mobility all in all, less dependent on the automobile. And all in all, this is also very beneficial to our challenges that we face in the time today. It has been mentioned before: climate protection, sustainable energy solutions, and smart connectivity. For mobility within the city, ladies and gentlemen, you all know the multimodal concepts because you're very familiar with maybe going by car on Monday to your work, and on Tuesday you choose the public transport, and on Wednesday you use a park and ride system, traveling by car first, going by foot on the second, or the public transport. So you combine all the potential models of mobility already. And what all these concepts have in common is that they all happen on the level of the surface, on the level of our built streets. Today, we are taking one step further, maybe taking two steps further, because we're not just taking different model concepts into our discussions consideration. We will talk about different dimensions of mobility within our cities. And we will look about the concepts of the city of the future, how traffic data can be bundled, and how mobility can be designed in a safe, reliable, and sustainable way. And at this point, ladies and gentlemen, I invite you all to free yourself from all ifs and buts, and also from the concerns that may be limiting you at this point of our symposium. I would like to invite you to come with us to our future, to a possible future of the visionary setting with unlimited possibilities, with diverse approaches and eye-opening perspectives. And making these visions accessible and understandable is a challenge in itself already. And then linking research, application, and industry in Germany and Japan is thematically a very special task. But you're still with DJW, so nothing is that impossible that easily. And I'm very pleased that we welcome today our keynote speaker, who combines all these dimensions: Germany, Japan, research and industry, and especially is a visionary speaker who I've come to know about in January this year, Professor Dr. Thomas Ortlepp. A warm welcome to you. I take maybe 30 seconds to introduce yourself and then hand over to a keynote. Professor Ortlepp was born in Thuringia. He's a trained maintenance mechanic. You studied mathematics at the TU Ilmenau and received your PhD in 2004 in the field of quantum electronics. In 2010, you habilitated in the field of microelectronics and subsequently took over the management of an industrial project for high-performance quantum memory circuits at the University of Berkeley in California. In 2013, lucky for us, you returned to Germany and started your career at the CIS Research Institute in Erfurt. In 2015, you also took over leadership of this institute and you hold this position up until today. And also 2015, additionally lucky for us, you were appointed distinguished professor at Yokohama National University. As I said, I was able to meet Professor Ortlepp at our Asanokai in Erfurt that we jointly co-organized with the LEG Thüringen, and I was immediately enthusiastic, and the enthusiasm seemed to be mutual as you accepted our invitation instantly, and you're here with us today, making room in all your travels and your busy schedule. The stage is yours.
Thank you very much. It's a great pleasure for me to be here at this unique place and also to have the opportunity to introduce you to this topic. And as it was already given as a kind of boundary condition, I will not give my concerns and any thoughts about what is the risk of this. I like to think about what is the possibility. What do we have? We have technologies, we have solutions, and what we can do when we combine them in a smart way. And of course, maybe at the end of this presentation, you will have a lot of questions. And that's the idea of the symposium, that we can discuss how we can solve this in the future. And now I like to get my presentation on the screen, but I don't know how it works. Someone will help me, I guess. And there was also a presenter promised to switch the slides. I was thinking about what is the biggest risk by introducing smart cities in the future. And I think from what is available, we have a lot of solutions in the technology. Even in the last hour, we could see what Panasonic industry can provide to this topic, but a lot of other research organizations, companies provide solutions. But the problem is that in a normal way, the market will adjust itself. So the company bring in innovations, it's presented by the marketing, the customer will accept this, and this is kind of a self-organizing thing that those solutions arrive at the end user. In case of a car, for instance, that's pretty normal that at the end of the day, maybe some political rules, but the customer selects which car he wants to buy. The smart city is much more difficult because the city is not something you do in marketing in general. There's many different things, and here I think the biggest demand is that there is a government way that it is introduced to change our existing cities and infrastructures to a totally new dimension. But let me start with my presentation and give you first some very general things. Oh, this is okay. The first number was already given in the first presentation, and let me try to go back. This is not working as I expected. No one before. This is the population density is one thing. When we think about cities, we can first think about the countries. I just collected briefly some numbers to give you some ideas. So the population density in people per square kilometer in 1950, it was for Japan something like 224, and then it increased, and the maximum point was in 2010. And we all know that the population is reducing since then. And there is an estimated value of maybe 275 people per square kilometer in 2050. For Germany, it is a similar scale, but a slightly different trend. In 2004 and 2018, we had the same maximum value of 237 people per square kilometer. But about since 91, it is stable. There's a small fluctuation. And I also collected some numbers from big cities. But of course, the metropolitan cities are much higher. And we have one big trend, which was already introduced at the beginning, that the number of people living in big cities will increase. And today, it's about 50%, but it will increase to about 70% in the future. And the day before yesterday, when I asked my daughter, she's 15, what do you think about a smart city? She was drawing this picture. So she draws some buildings and she draws some people. And I was surprised at the end of the day. She gave me the picture. I said, okay, I put it in my presentation. But then I asked her, oh, there's something missing. And there's no car. And then she said, oh, a city in the future will not have any car. Because we have to bring things close together and find smart ways that maybe work, maybe living, and maybe other areas are in a distance that I can easily access it. And maybe there's some underground connection with fast trains or anything else. So this was her idea. I didn't talk anything to her. I just said, draw a smart city for me. And I was surprised, and maybe this is something we can discuss later. And this slide just reminds you on the numbers I showed before. So by 2050, the estimation is that 70% of the world population will live in cities. That's a huge amount. And if you think about the numbers I showed before, about 6,000 people per square kilometer, it's a huge number. And the question is, for me, what is a ratio? So how many people per square kilometer is a good number to have a balance? So today people, when you go for a new job, they ask for work-life balance. But we should also ask for this balance in the density of cities, and everything will change with this trend. So our private life will change, the transportation of people will change, and also the transportation of goods will change. And if I speak about smart cities, I was looking for some definitions. Of course, you can find many definitions, and that's why I actually included 2 definitions. But of course, the first important thing is that those cities will use technology solutions. So I mentioned earlier, we have a lot of technologies already, but the idea is to apply them to improve the management and the efficiency of the whole environment I'm living in. And the biggest challenge from my viewpoint is how to manage this, because it influences everything, the private living, the transportation, but also the interface between all this. And what are the smart cities? So they have the traditional networks, but they will change. So they have to service and make efficient use of digital solutions. I need to connect all the data from everything. So what is the location of an object? What is the target? Where does it go? What is the condition? And maybe every minute I have to present different solutions. For instance, if my navigation system gives me a different track to my destination because conditions have changed. So this is one important thing. And the smart transportation, I think, is a topic on its own, which is not only in the city, it's also the transportation over much bigger areas. And the different levels of transportation. So we already heard about maybe it's not all on one surface. There's things below the surface, there's things in the sky, maybe some drones moving some small parcels. But I have to connect those levels because maybe the person comes with an airplane, goes on a train, goes on a taxi later, and I have to have efficient link points, efficient train stations, if you want to call it, and they maybe also change dynamically, because this is the place where you actually today lose most of the time, and maybe you also go lost at the transition points between the different transportations. And we have to think about what is necessary to collect all this data and to make the interfaces. And in my current job, we research new sensor solutions. So sensors are a very wide field. And I collected also some data to tell you how many sensors you have around you in the current situation. So actually, I didn't find data for 2023, but I found a very good study from Bosch from 2017. And it shows you that the estimated number of sensors which is active, which is kind of online or in use, is 7 trillion at this year for about 7 billion people. So if you just do the ratio, you end up with about 1,000 sensors per person as an average number over the whole world. So it means it holds for everybody in Africa as same as in Europe. And then you can think what is, for instance, in a car, you have typically around 100 sensors, number increasing. And in a smart home, you have a few tens of sensors, also numbers increasing. And in your smartphone, you have a lot of sensors. And if you think about other solutions like medical instruments, you also have sensors there. One thing which was introduced as a nice thing was the Google glasses 10 years ago. And today you have many more of these assistant systems which you can use. But the interesting point I like to make here is they are applied from the outside to assist yourself. But today, when I speak about sensors, we also consider sensors inside the human body. So it's 10 years later, and we have implemented sensors, and this number will also increase. And maybe this is something you are scared of, but in some areas it's already normal. And one device we develop in our company is, for instance, like a medical sensor which you wear in the ear, and it collects a lot of data for healthcare systems. And this is one of the things you have also as a layer in a smart city, that how you connect maybe older generations to the medical doctor. Does he have to travel every day to the doctor, or he has maybe a online connection, and we can collect things like the blood pressure with this sensor as a pure optical signal. This is very attractive solutions for patients which carry some risk in this field. And Japan has introduced this strategy of Society 5.0, while Germany was thinking about Industry 4.0. So the quality of living of people is most important, and this also includes these medical devices. But where you find sensors in the smart city, today if you think about the headlight of your car, it's not only a lamp, there's much more. Of course, the lamp has changed to LEDs, but this is just a yellow spot which you see on the slides. Typically, you have also a distance measurement system. It's a radar system, which might be implemented in the headlight, but also a LiDAR system, which gives you information about objects in front of the car and may help the car to do either autonomous driving or to assist the driver for not, let's say, creating any accidents. But of course, the other thing beside the sensors is the connection of all the cars, that you have position and maybe trajectory where it's moving, and it's interlinked. So from the point of safety, the best is all cars are just controlled by these connections by a computer and no human driver. The most critical thing which is seen by the engineers is if you have a lot of human drivers and a few autonomous cars. This is more risky when all cars are autonomous driving. And another instrument which you may find with a lot of sensors was introduced by Qualcomm, and they call it the doctor in the pocket. And some people may also be concerned that they don't want this, but it's coming more and more that you have wireless sensors, you have image technologies, and you have portable non-invasive laboratory equipment which you can bring to your home to measure conditions, collect all this data and transfer to the medical doctor to give advice what needs to be done. So these are all components carrying a lot of sensors. And I show you this number of 7 trillion active sensors. This is a recent YOL overview of MEMS sensors. MEMS stands for micro electromechanical systems. This is what we develop and produce in our company. And in this 9-year study here, you see that the sales volume has increased by almost a factor of 2, but it doesn't show the number of the devices. In the same period, those devices get much cheaper. So the trade volume goes up by a factor of 2 and the price goes down by to 10% in 10 years before. So this means 20 times more actual devices in 10 years. And this is increasing much faster already when the study predicted here. And some of the big increasing numbers coming from the very small sensors. Today we have seen in the exhibition sometimes some magnifying glasses, but what was underneath the glass was still visible. But some things are maybe much smaller. I will show you at the end of my presentation. And I collected 2 examples, and I'm sorry if I show a Chinese example here, but this is one example I found with some numbers. The city of Nanjing in China is the 11th biggest city there, and 8 million people live in this city, and they have a target to introduce a fully new transportation system. Currently, they have, for the 8 million people, about 1 million private cars, about 10,000 taxis and 7,000 buses. And if you would make the same statistics in Germany, it would look slightly different, because for 8 million people, we would have roughly 4 million private cars. But this is not possible in a smart city in the future. So even the number of 1 million cars creates massive traffic jams and makes, let's say, the efficiency and the sustainability of the city very low. And they want to think about this so-called next generation smart transportation system, where all moving objects get tracked. They have RFID systems, or they have navigation components, and their current position and their target destination for the whole day are tracked. So they collect massive data and try to run automation algorithms to find out what is the let's say, most efficient number of trains, of buses, of cars to transport all the people. And this is something which may not work in Germany or neither in Japan. They also say, oh, this person has to move to this spot to increase efficiency, because he lives on a, let's say, place which is not appropriate to his place where he works. So there might be, again, this problem that how to transform the existing cities. So Nanjing is a very old city with existing large infrastructure. How to transform this to a smart city is a very big question. Even if you have the solution for the smart city, you cannot build everything new on the green. So you have to think about this. But when I think about building something new on the green, Japan has made a nice approach. And the picture, which is weekly in the background, I took about 4 months ago to Mount Fuji. It's a small village which is many hundred years old, but in the vicinity of Mount Fuji, there is a big project started to build, let's say, a laboratory-size smart city with about 2,000 residents, but it's built on the green, so there is no, let's say, existing city transformed in it, and they will find the, let's say, most usable approach how the organization of transport and living areas is organized. And there is a small, let's say, introduction video which shows you how it might look like, but it doesn't show you the solutions to things, but it gives an idea that I found on several Nature articles that a good density for people is in the range of a few hundred per square kilometer. And this is what you can guess from this video. There was no skyscraper with 100 floors. There were buildings with like 3 or 4 floors, because this might be the living environment which people may think is very nice, and they feel well in this environment. And what are the challenges I can see without thinking about any concerns? We have 2 possible strategies. We can build totally new cities, but we also have to think about transforming existing cities. And then we have to think about what is the compromise between efficiency in the density and quality of living. From a mathematical standpoint, efficiency might end up with a total crazy solution for the people, because they don't want to accept this. And then this mixture, there's living areas, there's work areas, there's maybe shopping areas, there's also some, let's say, relaxing areas. So what is the good size of each? How is the interlink? And is it very small unit cells and many hundreds of them, or much bigger unit cells? These are questions. And we will have sensors inside all items. That's my opinion. They give you a location and they give you a condition of any of this item. And if I say item, I mean not only the cars or goods, parcels, I also mean the humans. So I know where the humans are, what are the conditions, vital parameters, identification. So the chip inside my arm opens the door. I have no key card which I may lose. And the last thing which I like to use to stimulate your thoughts. So the Google glasses are known, but we have micro-robots. If you look modern movies, you find these micro-robots, and they are not just science fiction, they are real. So this is a Nature paper from 2020, and you see a microscope image of a micro-robot near human cells. And today you can manufacture them in MEMS technologies, and they already exist in the laboratories. And you may go to your new employer and he asks you, oh, please drink this. And at the end of the day, he tells you, oh, you should see the doctor because of your liver issue. And you wonder why he says this, and say, oh, this tells me the sensor you just swallowed. And micro-robots are real. They are under development heavily. They carry a lot of MEMS technologies. And I'm pretty sure that they will be an important part of the smart city to provide all this identification and conditions of all items, not only the humans, but also any other item. This brings me to the end of the presentation, and I'm looking forward to exciting discussions and then exciting further presentations. Thank you.
Thank you very much, Professor Ortlepp. Maybe we allow yourself a little break and you take your seat again, because we have the Q&A session after the first panel, where I would like to also include you as well, if that is okay with you. With the first panel today, ladies and gentlemen, of our DJW Symposium, we will get into the design of our cities of our future. And I'm very pleased to welcome 3 experts with me on stage, who will look at the topic from very different angles, but you're all united by the background of innovation, of cooperation, and application orientation. I look forward to Mr. Peter Seiler, Alexander Schulz-Storz, and Takuya Taniguchi, if you would like to join me on stage. We missed the topics completely, but that is okay, I guess. Welcome, gentlemen, to the stage here with me, to our panel 1, to the first one of 2. And also, I would like to take the chance to introduce all of them to you, because I know you very well in the terms of our preparation. We had several talks going on. Mr. Taniguchi, you hold a degree of public policy from the Kyoto University. You have an MBA and also advanced global studies of the Paris School of International Affairs. You have served at the Ministry of Land, Infrastructure, Transport and Tourism of Japan, the Cabinet Secretariat, as well as the Cabinet Office in Japan. So since 2022, you have joined us here in Germany and in Munich, establishing DMP Europe and especially promoting smart mobility projects. And I can also say you are the person uniting the private as well as the public sector in our discussion today. Mr. Alexander Schulz-Storz, welcome. You hold a mechanical engineer and MBA at from the Open University Business School in the UK. You started your professional path as application engineer for combustion engines, followed by the technical sales function for British as well as Japanese OEMs. And at Panasonic Automotive, your first role was back in 2012 as director of new business, focusing on e-mobility concepts especially, followed by director sales for German and American OEMs in Europe. And your current scope is director cross-value and open innovation division since 2017. And you're also running this beautiful venue, the Panasonic Campus Munich, and was therefore one of the masterminding heads for us to be here today. Thank you very much. And Mr. Peter Seiler, he is an experienced urban development expert. You've worked in various countries, including China, Germany, and across Africa. You have more than 15 years of expertise in this industry, managing international projects relating to urban development, to energy efficiency, and renewable energy. And you've also worked for several renowned organizations, including the Deutsche Gesellschaft für internationale Zusammenarbeit, the GIZ, and you participated in a number of research projects associated with the planning of tourism, of urbanization and regional development. You also hold an MBA in international real estate management and have an engineering degree in urban regional planning from the TU of Berlin. Welcome all of you to stage. I was very impressed by the keynote speech by Professor Ortlepp, and I also know you took a rather visionary approach to solving our keynote speech and to approaching this topic. Mr. Seiler, maybe the GIZ or even yourself have a different view of what smart city means. What does it mean to you, smart city?
Yeah, thank you for having me here. And what is a smart city? I'm very grateful that Mr. Wiesheu and also Professor Ortlepp gave a big overview of what is a smart city. So it is about interconnectedness, and also like the photo of your daughter, the painting of your daughter, because she also included a very important aspect for me, the environment. So it is not only about being interconnected and combining different disciplines, but also look into the connection to the natural environment, not only built but also the natural, and of course efficiency as the overarching topic. It is of course digital technologies bring efficiency to a city. But what we also look into with our works at the International Smart Cities Network is to put the people at the center. So to look into some people-centered urban development supported by digital solutions that make cities not only livable, but also help them to compete in the, how to say, struggle for talent on a global level.
Putting the people and the citizens within the center of discussions also brings me to the next question to Mr. Schulz-Storz, because I know that Panasonic pursues also this project of making the city of the future serving people instead of things. And so my question is, how does Panasonic specifically move and drive this aspect forward, combined with the answer of Mr. Seiler, and which projects or which products does Panasonic produce, implement to make our city of the future smart?
Thank you very much for having us here, and thank you for your words and appreciation for our site. And I like as well the picture of the daughter of Professor Ortlepp. And there are two areas we're working on. One is the decarbonization, means many vehicles move from combustion engine to electrification. And the second thing is, I brought here some examples, going from analog to digital. So, and moving from analog to digital, you need to see what is the kind of, let's say, pollution in the air. So we have some sensors like particle measurement sensor. You cannot see the particles, PM 2.5, and this measures it. Yeah? And then you need energy for a sensor. So we have little solar cells. And then we transmit it with Wi-Fi or Bluetooth to a smartphone. So you can even have in a smaller area of your comfort zone or living zone the data on your smartphone, and you don't need a battery or cable, so it's wireless, and we support to see what's going on in the air. And the second part, when you look at transport and you have the, let's say, EV cars, you need to charge the car and you safeguard the car itself. So we are quite strong in cars with relays. We can switch on and off a battery. We can switch on and off a wall box charging system. And we have some photomos products inside. They monitor voltages or voltage ripple, and they can give the signal to the relay to switch on and off. So we are inside, and we have some modules or some key technologies, but we are not on the top layer like a car maker. We are tier 2, tier 3, tier N in that area of technology.
Thank you very much. Coming to the third question to Mr. Taniguchi, because I was already very impressed about the sensor technology that is possible today and also in the future. And also last year, we conducted our DJW Symposium about the aerospace industry, and coming both ways and methods to gather data, especially maybe from aerospace via satellite technology or maybe from Earth via sensor technology. We've heard about the range of what is possible there. In our case today, of course, keyword transportation and traffic routes, DMP is rather the building bridge between the really bundle and abundance of data available and putting them in a meaningful way to gather them, to interpret them, and to put them on maps. May it be on roads, may it be on people, may it be on moving subjects. How do you manage to build this bridge?
So thank you for having me. And before answering your question, let me tell you more about what we do. So we create three-dimensional high-definition map data, which is mainly used for autonomous driving system. But also we can use this map data, HD map data, for logistic solutions, smart city applications, or infrastructure management, and so on. And we create the most static data, like road structures and road networks, but now we are adding more dynamic information into our HD map data. For example, weather situation, traffic situation, or construction, and so on. So we need data from the sensors and many other various resources. And what we do, for example, is we are developing EV logistics simulations, because we need leading information to think about the most efficient EV logistics. So because the gradient or slopes has a significant impact on the energy consumption. So we get all the dynamic information and adding static data adding those data into our static data, we can create even more useful applications in terms of climate protection or smoothest logistics and so on. Yeah.
Maybe back to Panasonic. I also read that you, with the buzzword connectivity or connecting all the devices and the sensors, I also read that you do the street lamps that are to be one of the Wi-Fi connectors setting all this data. Is that correct, or?
Yeah, it's correct, partially. Inside the street lamps or any infrastructure product, there are probably devices like I showed here. And when you like to have a nice wireless grid, you need Bluetooth, Wi-Fi or other radio technologies. And then, of course, a street lamp or something can be a nice spot to multiply the touch points for the signals and to have a kind of mesh. So it's already existing, and we were investigating a lot topics to see on the roads in Germany. You have always these black, white plastic poles. You have 10 million in Germany, so maybe that can be as well a repeating spot for something like the street light or other things that are already there and can speed up this kind of technology introduction.
How does DMP collect all this data within the city?
So we are working with various partners about getting those information. So because we are basically the map developer, so we are working with public entities in Japan to do the research and development. And also in that project, we have various partners from telecommunication companies or transport companies. So by collecting those information and adding to our HD map data, we can create a dynamic map data, and that's the idea of our projects in Japan.
And when I think about all these digital approaches, and I'm also thinking about the devices that may be needed to implement all of the data correctly and very usable for the one like me, having the phone in my hand and just needing a specific set of information to get from A to B. I know I can handle my mobile phone or another device, but I also know that looking at Germany and Japan with the demographic change of a population getting increasingly older, that there may be a gap between the people who handle the digital devices quite natively and also the people who need to maybe have a hand guiding them to the use of these devices. And Mr. Seiler, maybe you can elaborate a little bit more about the challenge, also a bridge to be built between the demographic changes in Germany and in Japan as well, on the one hand, and the increasing digitization and the need for using devices properly.
Well, there is the gap, yes, I fully agree. And the challenge is, and this is also what, besides the people-centeredness, which leads to the second issue of leaving no one behind. So, of course, we do have large groups of the society that do know how to use digital applications, but we also know other parts that don't, for certain reasons, being age, as you mentioned, and that's why right now, whenever we look into some participatory processes that we, of course, you never can reach 100%, but still make available both options, the analog and the digital one, which of course in terms of implementation will lead to, let's say, some extra hours if you make analog information digital. But this is of course something that currently there's still the not only the need, but the necessity, and our understanding of participatory, or successful participatory processes to still enable analog modes of participation. Otherwise, you would lose not only valuable information, but also in the long run the acceptance of making cities smart, because it always depends on how to say, the way you communicate your ideas as an urban development authority. And the more you communicate, the higher the acceptance. And if you lock out large parts, then you will run in troubles in the long run.
I see your two heads nodding. Is there any thing to add, or just a pure agreement?
Well, one thing came up to my mind is about the data sharing is really important to create a common platform and common infrastructure. And one of the biggest challenges is about map data is, the big tech companies collect so many information and they don't share those with others, and that would make the very difficulty for other peoples to create other innovative technologies. And one very interesting initiative in Germany is that German government started the initiative called Mobility Data Space, which encourage each private companies to share data and encourage them to create new applications, innovative applications with each other. So those mutually beneficial initiative is very exciting for us to create the new projects, I guess.
What I can add is that, let's say, the part before you mentioned acceptance is important. You have an analog world, in a digital world, and you have a mixed world, and how to accept that. The younger generation, teenagers, or the generation in the mid-20s, all is digital, and they love EV cars. And they're already in these different modalities of traveling, like you introduced. But when you have maybe an older society and it's more analog, then how to manage that? And both, like the cars you mentioned, you have a self-driving car, then maybe the average speed goes down and it's pretty safe, and then suddenly a manually driven car comes in and then is disturbing the autonomous system. And there are many challenges, not technology challenges, maybe acceptance challenges. And that's very important, I think.
Would you like to add something, or?
Yeah, I think this issue of data ownership is a big problem. I mean, you mentioned the big tech companies create a lot of data, and all these trillion sensors, they create data, it's available, but it's not accessible from other parties. And this is necessary to turn the existing city infrastructure to be smart. But we need kind of a standard how the data is stored and how the access is controlled. If I develop and produce a sensor today, the sales price of the sensor, and it doesn't matter anymore, the value is the data is produced by the sensor, and not this product sensor, but the data has a value. And I see a big problem because it needs regulation which goes across companies, across technologies, how these are merged into one accessible system. You also have to think about concerns, data security, and so on.
Yeah, maybe there's also a difference between Germany and Japan in this issue, because Mr. Taniguchi, you also emphasized that DMP and your company, of course, the concept, if it's implemented perfectly, it works globally, because it has one concept and it collects data, scanning and screening the streets, and conducting it into a map accessible for everybody. But also you said there has to be citizens' participation. It has to be finding acceptance by the people living within the city. And my question would be, how does this acceptance differ in Germany and Japan? And I'm asking this question to you. I know it's very difficult and maybe a broad answer, but since you have worked both in Germany and in Japan, maybe you can share your first insights of how your work differs in Germany and Japan.
Well, it's a very interesting question, and well, there are some similarities and difference between Germany and Japan, and the difference, well, first similarity is about let me tell you about the difference first. So I think the difference is Japan is more centralized, in my opinion. So I think the Japanese government is likely to take a lead about the new technologies and creating the common platform or standard in the country. And local governments, people are likely to follow those initiatives. And on the other hand, in Germany, I think, from the political perspective, I think state governments play more significant roles in Germany, and they encourage innovation in each state, and sometimes they do it by themselves. For example, regarding the dynamic map, actually the Hamburg city government is now developing local dynamic map in the city. And that is very interesting. On the other hand, the key is how to scale those things to the federal level or even the European level. So maybe in Japan it's a bit faster to get the national standard or national direction, but for Japan, I think then the problem for Japan is how to make it global, how to be aligned with other countries. And in that sense, I think Japan and Germany should collaborate with each other to create a common standard or global platform to improve to make smart city happens. Because the similarity I feel is when it comes to the smart city, I think transportation modes is very similar. We do business in United States, and as you may know, people don't use the public transportation in US. I mean, in some cities like New York or LA, they do, but in many cities or counties, they don't use public transportations. But here in Europe, I think the behavior and the culture of the transportation is very similar between Japan and Europe or in Germany. So I think the collaboration between us is very beneficial, and we can apply what we do in Japan to Germany and vice versa. So, yeah, I'm not sure I can answer your question, but that's my feeling.
The most important key word I took away from your answer specifically was the collaboration between Germany and Japan. So there are chances also in the field of smart city. And I'm wondering, Mr. Seiler, is there, you talked about the projects and the program of Japanese government a little. We also heard about the Woven City in Japan already. What does the German governmental organizations or the government per se, is there any projects implementing that could lead us to the vision of a smart city in Germany?
Yes, there is. It's been running for quite some time now, 4 years, I believe. Started in 2019, so-called Model Project Smart Cities. So this is this is open to German municipalities, where they get funds and get support for on their vision to become a smart city. So what does it mean? Of course, you start first with an assessment, what you already have within your boundaries, and then develop a strategy where you want to go. where you want to end up as a smart city, what is being needed in terms of, how to say, funds, but also actions to be taken. And this shall serve in the end as, the term lighthouse has been used quite frequently in such cases, but should be scaled up and made use of by other cities with similar conditions. So this ranges from very small towns like 10,000 people up to Berlin with about to be 4 million. So there is some, of course, some domestic support by the government. And it is not only a one-time and one-year short-term support, but runs until, I believe, 2030.
And having Panasonic as one of the global players here with us at the panel, is there anything, if you had if you were in the single driving seat of this one, which kind of ideas or incentives would you like to have from the German government operating in Germany, if you had the full bag of wishes ahead of you?
Yeah, that's a very challenging question. But I would say, of course, you like to have a lot and immediately, but this is, of course, not possible. And as you said, Panasonic is a global technology company, let's say. And we have so many technologies, and we like to bring them quite speedy to the market. But I understand that with technology changes in the society or in families, in companies, in cities, takes maybe decade by decade, or 5 years by 5 years. So I would say decade by decade, or generation, part of generations to the next one. So maybe, I would like to wish more speed, maybe. But this is not so easy, because you need a common sense. Like, of course, in Japan, common sense is always important. And in this society-driven things, you need that. And this is, but I would say more speed in that. Because some other areas on the globe may be more speedy. So then speed, I think, is one critical competitive part of this, the transformation in technology. Yeah.
Mr. Taniguchi, would you like to add anything from the Japan side?
Yeah. Regarding the speed, I was it reminds me of the professor's presentation about the Chinese initiative. So I think the Chinese government is the fastest one, but the thing is, we cannot do like them. So I think what we have to do is we have to tell people why we should do this and how beneficial these initiatives are for society. For example, like climate protection or sustainability or inclusiveness. So I think, it's not only for the government's role, but also our role, like from the private sector. We should tell people how we can contribute to society with our technologies. So that's the key to raising the awareness of the people to speed up. Yeah.
I'm looking at the watch I have presented here, and I would also like to open the panel for questions from your side. Dr. Gumb.
Yeah, thank you much. As you might know, today is the 5th anniversary of the GDPR enforcement. So this also brings me to the question of a people-centric smart city where privacy is taken care of, which you have a legal basis for all this processing. So my question is, how can we work together between Germany and Japan to have a high quality of software that protects people, so people like to come here, and not like in other countries where you cannot bring electronic devices because all your data is being stolen. So how can this be tackled from a technical and organizational side?
Any ideas from your side? I know it's a very tough question, but when we talk about a very wide variety of data that you all collect, and Mr. Taniguchi, you also approached this issue with many companies being like a closed shop. They collect the data and they keep them for themselves, not not wanting or not allowing them to be shared and to have like an open source. But also on the other side, all this data is available, and we need to make sure that it is protected somehow and it doesn't get in the wrong hands. How do you see our data protected along the way of getting a smart city done?
I'm not sure I'm the right person to answer this question, but well, it's really tough. I think, well, I think my answer is the same. So first we have to do the right procedure to collect data from people to secure the privacy, and also we have to disclose why we need this and how we use this. I mean, from private sector's perspective, there's something we cannot disclose, I mean, from the business perspective, but I think we should do as much as possible to explain people, to convince people to get those data, about the private data.
I understand this as an answer of being reasonable and taking everybody as much with them along the way as possible, and not like having an inclusive approach of using the data and making sure that everybody knows what the data is being used for, and also making sure in the end that the data are only being used for in the way you've told the people. Further questions? Oh, yeah. I saw the first one, Idris Brockmann.
Thank you. So maybe just adding up on that, I'd love to have your opinion about getting the acceptance with communicating the added value. Lots of time also with GDPR, that's the same. When you communicate an added value, for instance, you can get some extra information material. If you input your data, people are actually ready to do that. But they are ready to do this most of the time on a very individual scale, so for themselves as private individuals. And about smart cities, we are talking most of the time about kind of collective advantages. And it's also very interesting that we have maybe a different view here between Japan and Germany. We tend to have a quite individualistic society here in Europe, and it's a bit different here in Japan. So I'd like to have your opinion on that. Is it a possible way of getting consent, just putting the emphasis on added value for individuals?
Is it directed to Mr. Taniguchi or any specific?
Thank you for the tough question. Well, yeah, I understand your point. I mean, as you mentioned, I think the benefits seems like not so direct to each person. So, yeah. So, however, I think on the other hand, so when we well, it's not the appropriate example, but when we use the Google data, we agreed to share our private data with them, even though we don't understand how they use our private data. But on the other hand, it's obvious that their service is improving by collecting our data. So I think it depends on the service quality that we provide by using those collective information. And if people understand that if the service is improving by sharing our data, I think they are happy to do it. So yeah, so my answer is we have to improve the user experience of the final end users to so that they can understand how valuable you to share your personal data is.
There were further questions. The lady in 2 rows in front of Mr. Yeah.
Berlin, and a couple of you mentioned the word efficient, and I think in the context of cities, efficient is quite a dangerous word, because cities are social systems, first of all, and they are not computers or machines. So, and therefore I would think we should more focus on the UN definition of resilient cities. That's what our cities are really threatened: water, transport, energy, food. These are the key issues. How can cities survive? And so it's not a question of having a few connected cars in the city. That's a complete, I think, utopian view, maybe dystopian view. But I think we need to make sure that we have inclusive transport system. And Japanese cities are very well known for being excellent walking and cycling cities. And that is resilient. So if your whole infrastructure is destroyed by the future climate emergency, you can still walk and cycle. And that's what we also see in the Ukraine. In the end, you can still take your bicycle and save your life.
But maybe I have to jump into defense of our panelists, because I made them answer the questions with regard to mobility transport of the future. But your comment is perfectly right. In the end, we all have some ways to just walk our ways to one A to B spot here.
I can give a little insight what we do, not only cars and people. So when you talk about the smart city, the focus is cars and people. But we started to look at waste, how to make waste management smart, or how you investigate the status of a district heating system, or making digitalization of a used water system from the Victorian ages in London. How to bring that to a digital platform that he can analyze data. So, and then we have challenges. I come back. What is the sensor to detect the waste? Yeah? Or what mix of sensors, or what kind of energy you need, or what radio you need. So we have many experiments on that area to provide a digitalization of different things or different topics, not only people and cars, or cars and people, or transport. So yeah, but it's not so easy to do that. And yeah, but we start that he can collect data. He need to get data from, let's say, the underground, and that's a challenge. Yeah.
There was one question from Johanna Schilling first.
Yeah, thank you very much, Johannes Schilling of ECOS. One comment and a question. Professor Ortlepp, when I saw the drawing of your daughter, it immediately reminded me of the last German-Japanese Environment and Energy Dialogue Forum, which we had last year in Berlin and organized together with NATO. Because that was about the role of cities on the way to net zero. And we had a very nice keynote there from Professor Kreuzig of the Technical University of Berlin, which focused on the future of emission-free cities. And it all evolved around car-free cities, so just the vision of your daughter, car-free cities, and also the concept and vision of the so-called 15-minute city, which means that everything you need in a city is within 15 minutes reach, so shopping, your job, schools, recreation facilities, everything. So that was a very interesting concept, and there's one question that is in my mind now when I think about car-free cities, because Germany and Japan both have very strong car industry. So what is this industry going to do if we have car-free cities in the future? And maybe the key is that it's not, that car-free doesn't mean mobility-free, but it's still mobility that is needed. So this is a question maybe also to companies like Panasonic, because you're also supplying the car industry. So what is your opinion on that?
Maybe I can jump in because but if you raise your hand, it's also an aspect of disruption, right? If we all see into the future of our cities and environmental-wise, we say, okay, we need various methods of transport or new means of transport. Spoiler, we will look at this at panel 2 after the break. So maybe the car is a status symbol, is our used way, our traditional way, or the conventional way from getting from A to B, but maybe it's not needed in the future. And also with the steam engine, for example, it was the state of the art back then. Now it's more of historical lessons to show the kids how like trains used to be driven from A to B. Maybe this is also a vision that comes with a car. We don't know yet. But you have something to add, maybe.
First of all, I like to say in Japan and in Germany, it's quite strong industry. And of course, we supply into the industry in both countries, let's say. But we can see that Panasonic is quite strong in the e-bike market, in the robot market, in delivery robots. So the other industry, let's say, start to prosper. And we find a balance. And maybe, like Professor Ortlepp said, there are areas that go for the urbanization, but still you have the countryside. And then maybe there's still the need for a car. And it's a kind of individual mobility versus structured mobility. So maybe as long as the people like to have individual mobility, maybe they like a car or an e-bike or cargo bike. So there are different modes of individual mobility and shared mobility or train mobility or whatever we see in panel 2. But still, I think it will live for quite a long time, the car.
Maybe we have time for one last question, Mr. Kretschel.
So, thank you all. Wonderful input, amazing, somehow also challenging. So, I have a question to you, Mr. Taniguchi. You talked about data sampling, that all the big techies have their data or our data already and don't open those. Now, I understand your model, we could bring data from Germany and Japan together, but then we have only these small 2 countries, of course, economically leaders, but the big globe, how do you want to cover this? Will there be a global standard, or what is your intention in the future, for the future?
Well, I think ideally it will be great if Germany and Japan, or even Europe and Japan, could create some standard or direction globally to achieve the data sharing, to achieve the smart cities. So I'm not sure it can be applied to other regions because, as I said, transportation modes are very different. But at least Europe and Japan, I think the city structures and road networks, those are very similar. So if we could create some standards together, I think that would be the good direction for the other regions as well. So that's the ideal thing we like to do by recommended governments. Yeah.
Perfect. Looking at the time, it's sharp 5:30. This gives me the perfect mode to leave you off in a short break. 15 minutes. We will gather back at 5:45 here on site. Also, the live stream 5:45. Please be back at your seats or wherever you are to watch YouTube live stream of the DJW channel. I would like to say thank you to Alexander Schulz-Storz, Mr. Taniguchi, Mr. Seiler. Thank you all for making your way to Ottobahn today. You are home, so thank you for having us. And please enjoy a short break. 5:45. We're back here. Thank you so much. Now we would like to continue our symposium with a lively discussion on panel 2. And during the break, I'm very happy. I've attended some lively discussions already. And we would now like to dive into, it has been said before, the specific levels and dimensions of transport within our potential smart city of the future. And I would like to invite with me on stage Mr. Gabriele Semino, Marc Schindler, it's not, it's Sandra Frühbecher and Michael Stein. Welcome. Perfect. Thank you so much. Welcome to our round 2, the panel discussion of our smart cities. And I would like to welcome Mr. Semino, who is a representative of the underground transportation route, Ms. Kübacher, who spontaneously jumped in on the surface level, so to say, and Mr. Stein for the air transportation routes. And we had several talks beforehand, and I know you a little bit better than maybe our audience knows you, so I take some time to introduce the three of you to everybody who's listening. Gabriele Semino, you have been involved with TUM Hyperloop initiative since 2016. You have been the project lead of the student initiative, and you also led the team to success in the SpaceX Hyperloop pod competitions in 2017 and 18. You also co-founded the NPO, which is behind this initiative, served as its chairman until 2022. And the TUM Hyperloop program is an interdisciplinary research effort of the TUM, and you're also following the goals of developing technology for ultra-fast, emission-free and effortless connection between mobility hubs. The program is also, allow me to add this currently building Europe's first passenger-sized Hyperloop demonstrator, happening to be right outside, and plans to begin testing mid-2023. Also, welcome Ottobahn representative Sandra Kübacher. You are a vehicle engineer, and I stumble with words a little because you quite spontaneously jumped in for Mr. Schindler, who fell ill today, so very well-being, hopefully very soon again. But you share your time. You have studied, or you are a vehicle engineer. You started to work at Ottobahn quite recently, but bring in a very lively dimension to the team, as I heard, and are just as perfect and capable of answering all our questions today. So welcome to the panel as well. And the completing puzzle of our panel number 2 is Michael Stein. He holds a degree of Masters of Science, Management and Innovation. You were part of the Young Professional program of TUM School of Management as well, and the Entrepreneurial Leadership program by Unternehmertum. He has been, or you have been part of Lilium also very recently, 2022. You're bringing the regional air mobility to its destination and developing operatable ground infrastructure for the jets, that are also called vertipods. And prior, you also worked for leading companies in energy, healthcare, mobility, and technology across Germany, UK, and the US. So welcome, three of you. Thank you for joining. And I want to start the panel with addressing my first question to Mr. Semino, because everybody here may know the term Hyperloop. Everybody might be very familiar with the concept behind it, because Elon Musk introduced it about 10 years ago, the concept itself. What is probably less known is what Hyperloop really means. Maybe we know the term, but not what is really in target behind it. And can you briefly introduce this initiative and take us by your hand and guide us what Hyperloop really is? And I would like to direct the first question as well. What specifically makes this type of transportation visionary?
First of all, thank you very much for having me. Thank you very much for being here. As discussed, yes, I've been involved with Hyperloop for a couple of years now. We started back in 2015 at TUM Hyperloop developing small prototypes for the competition that Elon Musk's company SpaceX organized. As discussed, this term Hyperloop is from a white paper by Elon Musk that was published in 2013, so roughly 10 years ago. And the concept itself is based on previous concept, but in principle, Hyperloop is about connecting cities inside a continent at very high speed. So the speed we are aiming for is the speed from an airplane by traveling on the ground, and therefore considerably reducing travel time. Moreover, the system is supposed to do using small vehicles that consume very little energy by traveling in a vacuum. It's always supposed to do direct connections, so you don't stop in between. All the people inside your vehicle, or we call them pods, travel to the same destination. They travel there directly without doing any stops in between. And finally, and actually quite importantly, the system is completely electric. So in a future where we have renewable energies, it could be operated completely emission-free. So this is kind of the main points about Hyperloop. As discussed, Elon Musk proposed this concept and kind of coined this name back in 2013, but he encouraged people all over the world to start working on it. And we are one of the initiatives, and there are several in the US and Europe that work on this. And we are all trying to make this technology happen. And Elon Musk itself is no longer involved, but there are many initiatives and many people that are picking this concept up for the future of continental travel inside of Europe, inside the US, and inside of every other continent.
And placing maybe the same, but also a different question to Ms. Kübacher, because for those of you who follow the Wissen vor 8, right before the Tagesschau several weeks ago or days ago, Ottobahn was also presented as one of the concepts. And for those of you who may have missed the broadcast, what makes Ottobahn special? And for you, also connected to the question, why should Ottobahn be part of the cities of our future?
So what is Ottobahn? We are also a transportation system that focuses on emission-free transport, but we don't focus, so we also want to cover it, but we don't focus on connecting the cities. We want to we focus on local transport, so get from A to B, where there are only buses, for example, or the, as you know it here, the connection is not that good to get to Taufkirchen. And we are having pods. You can see one on your right side. That's our cabin. And we are driving above today's ground. So we won't distract the traffic on the ground as Hyperloop and Lilium does. So we want to be an addition to the public transport of today. And we also drive on demand, so you order your Ottobahn and you go from A to B without stopping. You can do it privately, so it's like your own car, but you don't have to drive it by yourself. But you also can share it with other people that have the same goal. So we want to be an addition to today's public transport, emission-free and to your own needs, so you don't have to rely on the U-Bahn that is driving every 10 minutes and does not drive at all at night. And in addition to that, we want to focus on cargo, so cargo transport. So you perhaps you use your Ottobahn at day to get from A to B, and at night, where it's quiet and the Ottobahn is not needed by people, we can transport goods to the shops that we don't have all this small vehicles in the city of Munich in the morning that want to provide the stores with their goods. Yeah.
And why does Ottobahn need to be in the city of our futures?
Ottobahn is driving autonomously. I think autonomous driving is the concept of the future, but we don't know how to do it. We don't know how it will look like. We know it's there, it will be there. And Ottobahn has the advantage that it's its own ecosystem. We don't have we don't have people walking on our track because it's above ground, so you don't reach it, and it makes Ottobahn much more safe than driving on the ground or autonomous vehicles on the ground. Yeah.
third panelist on stage, Mr. Stein. Lilium's vision is actually to have a network of jets available that you can also order by an app individually, and I also suppose not only for people but for goods and deliveries as well. And what is the concept of Lilium exactly? And also, as I asked the previous ones, where does it head to be included within the city of our transportation routes of the future? Like, because I can imagine air transport, as soon as you leave the ground, transporting people becomes very maybe conflicting even with public acceptance, with licensing and with safety. How does Lilium meet this challenge?
Thank you. Also, thanks so much for having me. It's a pleasure to be here. It's quite a few questions in one. Let me start with the first one and try to get through it. So we at Lilium, we set out to build radically better ways of moving, because if we are looking into the cities of today, it's quite capital intensive, what we're having in terms of transport. High carbon emission and very time consuming. And this is really something where really Lilium comes in and delivers a new mode of transport to many cities and just a better way for others. And what do I mean by that? Well, first we fly, and we fly electrically. So at the end of the day, you can really imagine this a point-to-point connection, something like London Heathrow to London downtown. We do this by an electrical vertical takeoff and landing jet, so we can basically take off and land like a helicopter, but we are quite efficient in cruise flight, and this is how we then connect places. Public acceptance is a big topic. Yes, it's a new concept. We call it eVTOL, so electrical vertical takeoff and landing jet. Actually, when we look into the market, we have already countries, regions that have this sort of mobility today in form of helicopters. So in some areas, this is not even that new. And we have to really achieve to bring it to those regions where it might be something that is innovative, achieve this public acceptance, but I think also starting in those areas where this is already a common mode of transport, at least for some people, this will ease our market entry quite significantly.
That also circles back to the panel one discussion about public acceptance and using all these modes of taking the population with you by the hands, by the relatively new and visionary concepts of transport within the cities and connecting cities as well. Speaking of connecting, all your systems seem perfect for separate use. How would you like to connect? Maybe I live at spot A, and I know I want to take a Ottobahn to get to B, and then I want to use the jet to, I don't know, go to Berlin. With this, I don't want to go out of the system again. I want it to be a whole system. How would you see, as in your vision, that doesn't have to be a perfect technical answer to this, but to your vision, how would you like to connect all three of them? Because as you said, it's very capital intense, it's density building, etc. Yeah.
I think it's like, especially, I mean, this is what we're talking about when we talk about smart cities, to ideally connect all those modes of transport and really try to use all the unique value propositions of each system. I mean, as I understand Hyperloop, this is really something for long distance. So you go really from here in Munich to Berlin to stopping in Frankfurt, maybe Ottobahn, more like inner city context. We are targeting regional air mobility. So actually like quite a nice selection of solutions that complement each other. I think what we need to make sure is that those different modes of transport can be connected, can be booked together, so we achieve at the end of the day one flawless, one holistic passenger experience. And I think this is really also interesting today to just get into the discussion and also see how we can achieve that from now onwards.
You want to add something? I think you said it perfectly. We have to make sure that all the concepts of transport, there is not one solution for the transport. We have to combine many solutions, and we have to make sure, of course, that's our goal too, that it's very easy for the customer to book its flight, whatever, and use the combination of all that. It's very easy. You have to you book it with one tool, and you use different transportation systems as we have it today in Munich. I mean, you go from A to B, you go from bus to tram, and you don't have to buy individual tickets for this. Yeah.
The same question to Mr. Semino.
I think it's really hard to add anything else. I mean, as she said correctly, it's really hard to have one system do all the things. So actually, we looked at it from a Hyperloop perspective, and technically it's impossible probably. You want high speed if you go long distances, you want lower speeds and optimized systems for shorter distances, or you want to fly where it's easier. So every system has its own strength, and we just need to combine them. I think when you introduced me, you read what is in principle the mission statement that we use at TUM Hyperloop when we talk about mobility hubs. This is really important in the long term to think about the fact that all these different systems need to work together, and the place where they do is these hubs that in part can be the stations we have today that we can improve, partly will be new hubs where all these systems come together, where a Lilium jet can land at the top, an Ottobahn can drive in, and the Hyperloop can pick up the passengers and bring them to the next largest mobility hub. I think this is how we implement them all together. And then, as discussed, yes, obviously or hopefully, there will be digital solutions that make it very easy to switch from one to the next.
And we also had the question raised by Professor Ortlepp with his keynote speech this earlier on. He said that there are two solutions to implementing the systems. Number one, you rebuild the cities from scratch, which I deem rather impossible, but I learn from you. Or number two, you integrate your systems to the standing city in a very sustainable or reliable way. What would be your solution to implement your systems to the city existing already?
I mean, I think there is not really an alternative. So the systems need to, we need to build new infrastructure that we need to agree on. On the one side, it's a question about mobility challenges. So for having at least the same standard of mobility that we have today, we need new infrastructure, mostly from an environmental standpoint, but also because cities are constantly growing and increasing in size. So just to keep the current standard of living, we have to build new infrastructure. And ideally, we want to improve the standard of living. I mean, in Germany and Japan, we have very good standards of living, but we should always aim for better. And in particular, from an environmental perspective, we need electric systems, we need emission-free system, and in particular for the range we're talking about at Hyperloop, there is not a lot of alternatives that can really improve the mobility standards and also deliver on emission-free. So we need to build this new infrastructure. Now, obviously, building new infrastructure has a public acceptance problem, as we discussed before. It has obviously the issue of finding the space to do that. Obviously, you can try to go with existing right-of-way, but ideally, you manage to integrate this in the most sustainable way possible, in the simplest way possible. But we also need to learn to be able to build these infrastructures more efficiently. I think I will just speak for Germany for now. Germany has a big issue of building new infrastructure and better infrastructure, but we need it. There's not an option about this. It's really hard to discuss against it. So we need to learn how to do these things and build new infrastructure better. It's not just a problem for Hyperloop, it's a problem for every transportation system we will have to integrate in the cities of the future.
Same question to Ottobahn.
Yeah. First of all, we don't want to remove the trams and everything that's already there. We want to add our system where it's needed. But there are also cities in Germany, small cities, or everywhere around the globe, where you don't have any public transportation except maybe buses, but buses get stuck in traffic as every other car. So we need a solution that only needs the space that is left, and that's not a lot in most of the cities. So Ottobahn, we only use, I think it's 1.7 parking spaces per kilometer. So you can implement a Ottobahn in a really dense city without or only using 1.7 parking spaces, and we don't need them anymore if there's an Ottobahn going, because we don't need any more cars. Yeah, so I think it's a good sense of adding it to existing systems and implementing it where nothing else exists. And yeah.
Thank you. Same question to Lilium.
Yeah, it's a good question. I think for us it becomes more and more relevant now as we're going to the market. We are in the lucky position that the infrastructure that we need is comparatively like low in size, or small in size. However, it still poses a challenge, especially in the inner city locations. At the end of the day, I think it's important to ideally also combine certain infrastructure elements together. When we're talking about building, for example, a new Hauptbahnhof in Munich, ideally we can already think of integrating other solutions as well. For us, this means if you have seen like a helipad before, if you've flown a helicopter before, this is really the maximum infrastructure we need. But we already see it's tricky to get that. It's also tricky to get the energy there. And also, like when we're talking about the smart city, I think one of the biggest problems that we will be having with all the electrification of like all ways of mobility that we're having, to bring the power as its whole, but also bring the power to its destination. And this is currently the challenges that we are trying to solve and find the right partners to do so.
And I know about various other transportation routes within the city, or also from city to another city, taking place on the air level. Why is Lilium special? Competitors, maybe.
I think generally what makes us special is as we're talking about cities, the low infrastructure we need. I think this is really, in comparison to other modes of transport, our sweet spot. As well as like this, for some areas, new and exciting mobility concept that we are bringing, but for other cities, just like the superior passenger experience with this beautiful cabin that our founders and our engineers started to develop. And with regard to other alternatives in the air, so not only on ground, I think the unique thing about the Lilium jet is really that it's a jet. So we have engines, 30 of them. They are ducted fans, so we cover them to really make them noise efficient. And this is something that we have seen coming more and more to the locations, to the cities, that the complaints about noise, the complaints about like the pollution in general, if it's noise or if it's exhaust, plays a more and more vital role in choosing the right solution. Having it noise efficient, being able to use very little space is for us really the sweet spot that we're trying to hit, and also like the value proposition and the differentiating factor in the market also of air mobility, going away from open rotors of loud noisy elements to closed system. We looking into feeling and hearing the airstream, of course. I mean, this is air that that is going through the fans. But once you're in cruise flight, it's quite magical to see. So our current demonstrator is flying in Spain. It's quite magical to see once we really tilt our engines to the horizontal, and you really have to look for the jet, as you don't find it anymore. And when you see it and hear it, it's like it's really exciting to see where we're heading. And this is where we're going towards.
Perfect. I'm looking forward to that kind of future. But also, you raised a very interesting topic about pollution, and this is not just the combustion, but also the noise pollution. I can imagine, in my head, Ottobahn is a little quieter, but how about the Hyperloop?
I mean, one of the big advantages of Hyperloop is that having the tube and having the vehicles move through the tube make it very quiet, actually. So, like every train system or even maglev trains, you can hear them rolling by or moving by, but if you put them in a tube, they're quiet. So, I mean, we don't have the system running at full speed yet, so we haven't measured it, but the expectation is that it will be really, really quiet.
Does it also apply to Ottobahn being really quiet? Because the German citizen, I know I can literally hear and feel the complaints rising in already. So with all your new systems, is it noise efficient?
Of course, there is a certain amount of noise. We cannot avoid that, but we are using railway technology, and there are a lot of solutions out there to reduce the noise. So I don't see the noise as a problem at all, to be honest. But we haven't been able to test it on our test track yet. So ask me in a year. And I'll tell you, but currently we are not doing anything for the noise pollution because we don't know the noise yet. So we want to measure it and measure the source of the noise, and then we will do something against it, of course.
Perfect. I think this is the perfect setting of mind to know these challenges may arise, and we're already aware of it, and maybe we have to tackle them in the very close future. Looking at the time, we have some time left for your questions again. And I saw many people raising your hands beforehand. I would like to give you the opportunity to do just the same. Oh. First Ms. Schilling, then Mr. Musa.
Yeah, one question to Hyperloop and one question to the Ottobahn. So this is really a very interesting concept, I think, and kind of converting a quite old idea and technology into something new, because the Ottobahn reminds me of the Wuppertal-Schwebebahn, which dates back to the 19th century, and the Hyperloop is something like the Rohrpost, I think, so a postal service by tubes, which was used in some official buildings, or is still in use today. So regarding the Ottobahn, I understand it's a mobility service on demand, is that right? So if I want to enter, I call it, and then it lowers down from 10-meter height to street level. I can enter and I can go wherever I want. So I just try to imagine how it works in a city and how dense the grid, the track grid is planned to be, so that I can reach many points in the city. That's the question to Ottobahn. And then to Hyperloop, I understand you're focusing on transport of persons. Did you ever think about using Hyperloop also for goods transport on long distances? Yeah.
Okay. So perfectly right. Yeah, we are on-demand system. You will order your cabin, and it goes wherever you want without changing the cabin. And of course, you have to be on the track. So if you really want to have a city and go from A to B, from every point you're standing right now, you have to have a really, really dense grid. But as long as you are along the track, you can decide where you start, and you can decide where you end your ride. And I forgot the second part of the question. What was it? Oh, the second part of my answer. Oh, of course, the density. Sorry, I'm not used to sitting in front of people and talking to them. I'm sitting in front of my desk almost all the time. So if you imagine a Marienplatz, I mean, we don't want to build our Ottobahn and Marienplatz. We got the S-Bahn there. It doesn't make sense. So there are a lot of people. You have to build some switches where the cabins can go and what is on board and off board passengers, and like next to the switch where there will be a line there where the cabins can go that don't want to stop there. So depending on the what is it, mass of people, you can build a denser track and have more switches, because we know in advance where a lot of people will be, and if we don't know it in advance, it's very easy to add the switch. So we don't have a problem if a region gets a lot more people than it has had like 5 years ago when we planned the thing. And we are an autonomously driven system, so we always know which cabin will go where. So if, for example, cabin A will stop on the next track, I will take the cabin B and line it in front of cabin A so that it doesn't disturb cabin B. Yeah.
About the question about Hyperloop, so our main focus is people, because we believe that the advantage for people is way bigger. So if you want to be in Berlin in 40 minutes, then Hyperloop is the solution you want. Now with cargo, so the system is designed in a way that it's mainly for people, but cargo can also be transported. Now the thing with cargo is, however, that cargo is not so often needed that quickly. I mean, there is a limited amount of cargo that needs these high speeds, but it's relatively small. I think organ transport is something that is mentioned from time to time, but how often does it happen? For cargo, speed is less important, and capacity and low cost are more important. And so what we believe is that if we transport people with Hyperloop, which has these high speeds, which are more important for people, then, for instance, the rail system that we already have could take over the cargo capacity. Like we were when discussing with Deutsche Bahn, for instance, every time they take an ICE, so a high-speed train, from the track, they can fit 3 cargo trains in that same spot. So this would massively increase the capacity for cargo using rail, and Hyperloop could be used for passengers. And I think also from a market perspective for Hyperloop, I think somebody said it best: if you transport 80 kilograms of person, you can get considerably more money than if you transport 80 kilograms of cargo. So also from a financial point of view, it makes sense to focus on the passenger aspect. But as Ottobahn mentioned before, at night, where the capacity is not needed for people, you could transport cargo. So the system can do both, but the focus is on people.
There was another question, Mr. Musa.
Sorry, thank you. I actually wanted to ask the same question on freight and Hyperloop, but let me then rephrase my question to give you a chance to answer another one, also directed towards Hyperloop, if that's okay. Just recently, just a few weeks back, Hyperloop TT, one of your competitors, won a tender in Italy. They are now in the deal for building an about 50-kilometer route from Venice to Panur, which is also in Italy. I was wondering what your current opinion is on the investment climate towards Hyperloop. So we now saw one tender, there will be 800 million euros spent. How many more tenders do you see coming, and do you think that some actors are more willing currently to spend? Who would that be, and why, and how can we convince other actors to maybe get into the game as well and invest into Hyperloop?
I think the project you're mentioning in Italy is quite interesting indeed. Although this would be a project only focused on cargo, which, as I mentioned right away, I don't believe is the best application, but they seem to see this need. In principle, what they have there in Italy is a very specific application, which is that they have a port near Venice, and that they have a very high density of logistical density there, and they want to bring the cargo out of this port and into the next logistics center. It's a very specific application that I would believe the system required to solve this problem efficiently is not necessarily the same system you want to connect a continent to each other. I think where we see the focus to what we actually believe Hyperloop is good for is at the European Union level and also at the local level. If I can speak for Bavaria, since we are in contact with the quite in close contact and we're financed by the Bavarian state. But also at the European level, there is already some indications that they want to include Hyperloop in the planning for the corridors in principle for passenger transport in Europe. And there is a lot of input there coming about what they need for this planning, but it's also interesting to see what tenders will come out of this intent to include Hyperloop, since Hyperloop in principle is still in development. I think there is a lot of things coming, there's a lot of interest. The system at the same time is in development, so the two things need to come together. I will look very closely at what happens in Italy, also because I'm Italian originally, so I have a personal interest there. But there is a very specific application for I would call it a derivative of the Hyperloop system. I think for Hyperloop we should keep our focus on where the big advantage is, as a continent in particular, to transport passengers at high speed.
Ms. Stevens.
Hello, also a question to you. If you're talking about vacuum, and I'm coming from a productional engineering environment, where we usually say, oh, wherever you use, for example, a vacuum for pick and place, you better do it mechanically or electromechanically, because it's cheaper, because the energy costs have been just skyrocketing. Now we're talking about rather large tubes which need to be vacuumized or devacuated. The question is now, it might have been a very intriguing idea up to, let's say, 2 years ago. The question is the operating costs just for keeping the vacuum up. What are the challenges? How realistic is it? Or is the idea of Hyperloop possibly superseded by energy efficiency requirements these days?
Actually, I would argue that it's the other way around. So the thing with the tubes, so the most important thing to think about is that the evacuating the tube and bringing them into a vacuum. By the way, when we speak about vacuum, we're talking about 1% of the atmospheric pressure. Depending on the application, this is not considered vacuum. We say vacuum for simplicity; it's actually low pressure environment. So the bringing from 1 atmosphere, so normal pressure, to the operating pressure is a thing you ideally have to do only once. And then you just need to keep that pressure. So you only need to remove the air from the tube that leaks into the tube. And so the main point there is to reduce this leakage as much as possible. One of the reasons why we're building the test stand that you can see afterwards next here is to actually measure this leakage. And the current results that we have are very promising on the fact that this leakage rate is very, very low. Obviously, if you build it over very long distances, which we haven't done so far, you have to measure again and make sure that this can still be kept. But the projection is that your leakage is so low that the energy consumed for keeping the vacuum is also really low. And again, as I mentioned, since we haven't tested the system of full speed, this is mostly projection. But the projected energy consumption per passengers per kilometer is a factor of magnitude, like an order of magnitude lower than air travel and even lower than high-speed train, although the speed is considerably higher. So this is, again, all projections, but not considering or even considering the initial energy consumption of bringing the vacuum level. When you consider operation, the energy consumption should be even lower than high-speed rail. So actually, I would argue, given the energy prices, this is an advantage for a Hyperloop system.
But allow me to pick up on the energy issue. I mean, you're all electrified alternatives to cars, for example, today. How do you keep this cost increasement into your business plans? Because supposedly it's not going to get much cheaper again.
Yeah, just quickly. I mean, the thing there is to just make sure that you're as efficient as possible, and for us this means energy consumption per passenger per kilometer, which also plays directly into ticket prices long term. So when it comes to technical decisions, it gets more and more important to make sure that you reduce the energy consumption as much as possible. But this is a general problem, since Hyperloop needs to be a solution for the energy crisis, but also the climate crisis that we have. These two things play very closely in getting the system electrified is the first step, but making it as efficient as possible is connected, so in the development is very relevant.
Of course, I totally agree. One advantage of the Ottobahn is that we have space left above our track, so we can use this space to easily implement solar panels. And according to our calculations right now, we are climate positive, so the space on the track is enough to feed our system, and we even can give some electricity back into the system. So I don't see that as a problem. And yeah, in addition, efficiency, that's the point. So you can do a lot with aerodynamics with today's tools. So you have to make sure that you're very, very aerodynamic. I don't know if that's the correct word in English. And in addition to that, there's I forgot my word again. Sorry. I think that's it.
You remembered in a bit of time.
I think also fuel prices have a similar development. So at the end of the day, the question is, what's the alternative? Yes, efficiency is key. So there's not too much to add. But when we also look into carbon taxes that increase, this is one of the development that just countersteer this. So at the end of the day, even though we have rising electricity prices, this might be long-term even the better and cheaper option than actually focusing on conventional way of propelling movement.
I have a look to the audience and I see one further question.
Hello, my name is Karen Funkirep. Gabriela, I have a question to you. You mentioned that in Germany we need to speed up things because other countries are more advanced than we are. Do you think that this sense of urgency is already recognized in Berlin or Brussels? And how would I have to imagine, is there like an umbrella organization that brings like organization or developments like we have them at the stage right now together at one table to get this interconnection that Anne Pömsel also mentioned at the very beginning? This is apparently very important. And a final note, Sandra, you're doing a fantastic job at the panel, so no worries. Thank you.
I mean, I don't think it's necessary. Is it working? Okay, now it's working again. So I don't think it's necessarily for Germany a thing about other places being quicker. It's just also a point of having a climate crisis. It's not getting easier on us. So I think the urgency is more and more recognizable. I won't judge whether it's clear enough or urgent enough. I think the more we hear about public discourse, it's clearer and clearer what we need to do, and it gets clearer and clearer that we need to build new infrastructure. It doesn't necessarily convert in public acceptance for new infrastructure, and maybe that's the issue. So I think more and more people recognize the urgency, but not necessarily accept more what it means in terms of infrastructure. On the other side, and we had a discussion about this with some representative from Berlin, from the state government, that we have some issues with some of big infrastructure projects that we had in Germany that have, and without naming them, but everybody knows which ones they are, that are taking longer and are getting more expensive. And this is what we think nowadays about infrastructure in Germany. We think it's inefficient, we think if it's state finance, it's going to cost more and take way too long. And it wasn't always like this. Like, I mean, I wasn't born yet, but I was told that some years ago it was way better. And I think we have to go back to this, and we need to go back to this. I mean, it's not only a thing that Hyperloop itself will do, so I cannot speak alone for this, but I think as a society and as also from a governmental point of view, I just think that there is a need, and we know about the urgency, but we also need to recognize the need to get better at building this kind of infrastructure. And I think about the point about bringing all these concepts together, I'm not aware of what the right institution is to do that. I just think that the European Union, which is the most relevant for Hyperloop, since there's a system that is supposed to connect over state boundaries. It's trying to do this. It's trying also for Hyperloop to bring together different Hyperloop concepts from different areas of Europe to actually build a European system. But ideally, yes, we should also try to bring together other systems locally, because Hyperloop itself won't solve any issues if it's not well connected, as we mentioned earlier. And so we need to try to get the best connection possible to every other system, the systems that we do have right now, and systems that hopefully will be coming soon.
Perfect. Oh. Do you have the strength for 2 more questions? Perfect.
Okay, thank you for the great discussion. Here is DJW, so I would like to ask about Japan. So I am not sure you both, all of you are working about Japan, but I would like to ask about what do you think about the possibility or difficulty to install your solutions to Japan?
So maybe if I can start first. So Japan has a very good rail system. I was in Japan a couple of months ago, and I could witness it myself, and having a minute precision when going high speed is very impressive from a German point of view. And I think Japan is also working itself on a maglev system. I think one of the like from a technical point of view, one of the boundaries that Japan has that is less important for Germany in particular, but in general for Europe, is earthquake stability. This is one of the reasons that the maglev system developed in Japan is different than any other maglev system that's developed somewhere else. And the other question is what speed is needed in a specific region. So I think with the maglev system Japan is currently developing is quite good and probably best for the Japanese geography mainly. But Hyperloop would be even faster, so we should look into that probably. Yeah, so I think that the two systems improve considerably on high-speed rail, and more probably due to the earthquake problematic in particular, the Japanese maglev is better for Japan.
To be honest, I've never been to Japan, so I cannot comment the trains there. I don't see. So of course it's challenging to go to another city, especially if it's not in Europe, because we focus on the certificates in Europe right now, but I don't see it as a problem, or it will be a problem to adapt to other countries. And of course, yeah, the earthquake situation is quite challenging. Of course, I don't know the numbers for Ottobahn. Of course, we have to get the certificates, we have to consider earthquakes, but we are currently building our test track here next to Panasonic. So the earthquake situation here is quite okay, but I think it's a challenge we can manage, yeah.
So I think like same challenges, quite well connected railroad. At the end of the day, the way we are targeting market is looking into how can we make it better for passengers, for people out there. We are primarily targeting areas where existing transport is quite time-consuming, maybe carbon-heavy, so generally challenging. However, I do still think that Japan is a very interesting market for the Lilium jet. All around the big cities, Tokyo, Osaka, I think very interesting to bring regional air mobility. So again, so we have a range at the beginning of 175 kilometers. So this is quite a nice radius that you can fly around. I think one route that I just explored recently is Oita downtown to the airport, because you cross water. So this is generally a bit more difficult. I think by car, by train, you take around 2 hours around. I mean, with a jet, it would be significantly more time saving. Another thing is obviously, and this is always with new modes of transport, and I would be also curious to talk a bit about this, is cost, is ticket price. And I would say in Japan, in those areas, the general willingness to pay might be a bit higher. At the end of the day, we set out to be a vehicle for mass transport, but it always needs to happen step by step. And for us, this is a bit like the approach similar to what Tesla did, starting with the Roadster, going to the Model S, until at some point arriving at the Model 3. Ideally, it won't take us that long, but it will be a bit more of a premium service in the beginning, naturally. I would also love to comment on the speed of our region here. We were actually quite positively surprised by also this strong movement of EASA. So this is our certifying body, and this is also the difficulty when you move via air. So you really have high safety standards, and this was very important for us from the beginning to certify this in a way that it's trusted and it's safe. So our jet is certified like an Airbus A320, so quite high safety standards, and at the end of the day, EASA created together with us, so we were working with EASA for many years now, created with us the regulations that we can now certify our aircraft against, because without the regulatory body, without the regulation, we don't have a product. And I think this is very much appreciated, and this also is the last point to Japan. We have to adapt to the regulatory system there to also make the Lilium jet work, but we're working on it, so. Looking forward.
This is also a perfect example of how governments and politics and regulations have to comply with what is happening in the industry, and maybe they need more of a platform to exchange. Maybe sometimes politics is ahead of time. Maybe more of the times industry is ahead of times, and they have to match somehow to not mismatch, but to go hand in hand to create the future. Thank you very much. There's one more question.
My name is Yuriko Matsunami from Enobyte GmbH. Thank you very much for the very interesting talk, and I'd like to hear your opinion on a very simple question. From my personal interesting, what is the smart city for each speaker?
Maybe I can add to this one, because this one was going to be my final question to them as well. I have it in writing. So, closing question, in your city of the future scenario, which feature are you most looking forward to, and what does smart city mean to you?
I think for me personally, it's connectedness, to really find, and I think this is something we can all relate to, booking travels from A to B. First you have so many options, but there is options that are also superior. So having a support in that city to choose the right mode of transport for the right trip that you're doing to the right time. And this will probably covering peaks, this will cover distance, this will cover pollution, this will cover noise, and with this, smartness in the city, I think this helps us all a lot from a passenger perspective, so from our perspective. So this is a bit my personal view on a smart city.
Smart city, it's actually, I want to tell you about my day today. Around like 1 p.m., I knew I had to come here. I had to be here. I had meetings today. I was working. I don't have a car. Yeah. And then I needed to get a car. The battery was down, so I had needed another car to help me start my car. And then I was here right on time for the talk. So in the future, if I know at 1 p.m. I have to be here at 5 o'clock, I wanna use my phone, say, okay, at 4 o'clock or whatever, or no, not 4 o'clock, but 4:40, because I only need 20 minutes instead of an hour by public transport. I want to tell my phone, okay, I want to be here at 5 o'clock, do it. So that's for me a smart city without any negative impact on the environment. So yeah, going from A to B without driving by myself, without having to take care of it, and without any emissions. Yeah.
Yeah, I think I just can add on this. So I think, in particular, when we discussed about Hyperloop, it's also about long distance travel, and my personal experience, and maybe for some people it's different, but my personal experience is always quite stressful. It's not only about getting here from Munich city center, but now if I have to go to Berlin to the next meeting or to the next event, it even gets even more complicated. I need even more combinations, making sure about the time, if there is any delay, which is something in Germany happens from time to time, then I need to take that in account, so I need to plan with enough time and so on. And this fact that traveling right now is so stressful, both in the cities and between cities, is something that maybe in the future we can try to get rid of. So the phone should do all the work, or the server behind it, or the cloud behind it should do all the work, and then the technology should play well with it, that we can easily go wherever we want to. And so ideally all the systems work together, and with one click, or with few clicks or taps on the phone, we can go wherever we want.
So maybe I can summarize, it has to be connected, emission-free, and on-time freedom of choice of your transportation route for the cities of our future. And I really hope, because I'm excited about technology, to see all your systems being implemented. Maybe in 5 years' time, maybe in 10 years' time, who knows? They're all very at the start. You are in the funding phase. You're all looking for investors, but also being registered in Germany and Europe, and maybe once in a time all over the world and globally. So I'm keeping my fingers crossed for all your different levels of transportation, for all your connectiveness. I love the idea of being environmental friendly and being not dependent on the conventional modes of transport and traffic. And I'm looking forward to seeing you again sometime soon, sometime very soon, hopefully. And talking about seeing each other again, I have the time here with me. We have about 10 minutes left for our symposium, but I think it was a very closing question, and I would like to close panel 2 as well. And before we dive into the networking session, we have a little reception prepared. There's little snacks and dinner for you waiting already. I would like to ask our deputy chairman, Mr. Narukawa, to hold a brief word of closing, and to open the reception. I would like to thank you as well for your time, for making the effort to come here at the notice of 1 p.m. So thank you very much to the discussion and to your insights. Thank you. Okay.
Thank you very much for participating in the DJW Symposium. Today, the theme is the symposium. It was a smart city and various meanings. I was president of Japanese real estate development companies. And now I'm an independent director of Mitsubishi Estate, real estate. And today, I'm very able to learn about the smart city movement that is being promoted in Europe. It was very interesting and very helpful for Japanese society. Due to the rapid urbanization, there are concerns that traffic congestion, water and energy supply problems, sewage and waste disposal problem will become more serious. In addition, a global issue such as increased disasters due to climate change and circumstances against infectious diseases such as new coronavirus have emerged. The importance of smart cities is increasing as a solution of these issues. In Japan today, smart city project that utilize the digital technology is underway. Using cutting-edge technology that fuses cyber and physical. It is an initiative that aims to build a human-centered society while balancing social problem solving and economic development. Japan's strength lies in its experience and know-how cultivated through various urban development projects in Japan and overseas. Based on such experience and know-how, Japan aims to build an open and highly transparent smart city in which many citizens and companies can participate. On July 2020, the Tokyo Metropolitan Government announced that it would select the support in 3 projects to promote Smart Tokyo. One of the selected projects is Otemachi Marunouchi Yais Yurakucho District Smart City Project centered on Mitsubishi Estate. This district is located between Tokyo Station and Imperial Palace. The project area covers approximately 120 hectares with a working population of about 280,000 people and 4,300 companies. It is one of Japan's leading business districts. We would like to promote the smart city in this place and enhance the international competitiveness of Japanese economy. In November of this year, we will hold a symposium on the same theme, smart city theme, in Japan. So I think we can introduce Mitsubishi Estate's Smart City Movement project. If it is convenience for you, please come to Japan and participate in the symposium. Thank you very much today.
Thank you very much, ladies and gentlemen, for bearing with us. It has been quite a challenging but also very informative evening and night, especially in Japan, if you're watching via the live stream. So thank you very much for joining us today. Maybe to lose the last words about our network, DJW, Nichidoku Sangyo Kyokai, we have 1,011 members, both in Germany as well as in Japan, covering all the industries you can think of, being of a private person as well of the institutions and companies as well, of course. So, having said this, you're all invited to do two things: to join our network, to become a member, and number two, to join us at the networking session. We have a little snacks prepared, so please chat, continue your talks, and feel free to get connected. And thank you very much for attending. Thank you for all the panelists, Mr. Ortlepp, for joining us today. And I leave you off to it. And one last remark, at 7:30, so in about half an hour, we will, if you would like to, meet at the Ottobahn pod, if you want to have a closer look, if you want to have a guided tour. And also, right afterwards, we will combine it with the TUM Hyperloop demonstrator, which is right outside. So there is going to be a demonstration as well for everybody joining. Lilium Jet will be next in 2 years, maybe, here at Panasonic campus as well. But there's also demonstrations going on. But 7:30 at the pod for meeting to the guided tour. So thank you very much. Enjoy, have fun, stay well.